Hey everyone! Today we're tackling a fun Leetcode problem called Count and Say. It sounds a bit strange, right? But don't worry, it's actually about generating a sequence of strings based on a simple rule. We'll break it down step by step. Let's get started. Okay, so here's the official description. The main idea is this. We have a sequence of digit strings. The very first one is just to get the next string in the sequence, you have to read out loud the previous string, counting groups of identical digits. So you're basically describing the string before it. We're given a number, and our job is to figure out what the north string in this sequence looks like. Simple enough goal, right? The trick is in how we generate each step. Let's walk through the example where n equals 4. We start with the first term, which is always. Now, for the second term, we look at how do we read it. We say 1. So the second term becomes, got it? Okay, next. For the third term, we look at how do we read that. We see two ones together, so we say 2 1s. That gives us almost there. For the fourth term, we read it group by group. First there's 1 2, then there's 1 1. Putting that together, we get, and that's our answer for n equals 4. See the pattern? You describe the groups of digits in the previous string. So how do we actually build this north string? The definition itself gives us the process. It's naturally iterative, or you could think of it recursively, but iteration is probably simpler to code. We know the first term is, that's our starting point, our base case. Then, if we want, say, the fourth term, we need to generate the second term first, then use the second to generate the third, and then use the third to generate the fourth. So, we can just loop, starting from the second term up to the north term we need. Inside the loop, we'll perform that count and say process on the string we generated in the previous step. Okay, let's focus on that core count and say step. How do we take one string, like, and generate the next one? We need to walk through the input string, say from left to right. We'll keep a count. Let's say we start at the first character. The count is 1. Then we look ahead. Is the next character also a nope? It's a pivot. So, the group of n's. We take the count, which was 1, and the digit, and add them to our new string. So it starts with, now we move to the next character, the count resets to 1. We look ahead, oops, we're at the end of the string. So the group of n's here, we append the count 1 and the digit to our result. Now it's, and we're done with the input string. That's the basic idea. Scan, count consecutive digits, and when the digit changes or the string ends, record the count and the digit. Alright, here's the Python code that implements this iterative approach. Don't worry if it looks a bit dense at first glance. We'll break down the important parts next. You can see the base case for n equals 1 right at the top. Then there's a loop that runs n-1 times. That's how we get from the first term up to the north term. Inside, it builds the string based on the. So this first part sets up the process. We start with our initial string. The loop runs exactly n1 times. Why? Because if we start at term 1, we need 1 step to get to term 2, 2 steps to get to term 3, and so on. n1 steps to get to term n. Inside this loop, we'll calculate the next string in the sequence. After we calculate it, we update our current underscore result, so it's ready for the next iteration. Finally, after the loop finishes, the current underscore result holds the north term, which we return. Now inside that main loop, this is where the magic happens, the actual count and say. We initialize an empty string for the next result. We use a pointer I to walk through the current underscore result string. For each position I, we figure out what digit we're looking at and initialize its count to 1. Then we use a second pointer j to look ahead and see how many more times that same digit appears consecutively. That inner while loop increments the count and moves j forward as long as the digits match. Once the digits stop matching or we hit the end of the string, that inner loop finishes. We then append the count, convert it to a string, and the current underscore digit to our next underscore result. Finally, and this is important, we move our main pointer I directly to where j stopped. This skips over the digits we just counted, putting us right at the beginning of the next group. Okay, let's talk efficiency. How fast is this? Well, the outer loop runs n times, or rather n1 times. Inside the loop, we iterate through the current string. Now, these strings can get pretty long. Let's say L is the maximum length the string reaches. The time complexity is roughly proportional to n times L. So, big O of n times L. What about memory, the space we use? We need to store the current string and build the next string. The space needed is dominated by the longest string we generate, which is L. so the space complexity is big O of L. It's not super fast if n gets large because L grows quickly, but for typical constraints like n up to 30, it's perfectly fine. So let's quickly recap the main points. The count and say sequence has a unique generation rule. You read out loud the groups of digits in the previous term to make the next one. The most straightforward way to solve this is to start with and iteratively build each subsequent term until you reach the north one. The key part of the code is that inner loop structure which scans the current string, counts up consecutive identical digits, and then appends that count and the digit itself to build the next string in the sequence. Hope that explanation made the count and say problem clear. If this walkthrough helped you out, please hit that like button, consider subscribing for more Leetcode explanations, and feel free to leave a comment if you have any questions, or maybe a different way to think about it. And hey, if you're feeling extra awesome, the Boba Fund is always appreciated. Keep practicing, keep coding, and I'll see you in the next video.